R5, finding x and y intercepts of linear and quadratic equations. The deal with this is the whole concept or idea for finding x and y intercepts. I mean, I understand that if you put this on a piece of graph paper, you should know that this is your x-axis and this is your y-axis. Key points on a piece of, a graph that shows up is where does it hit the x-axis? Where does it hit the y-axis? Stuff like that, Maybe it has a couple different places, maybe it has two x-intercepts and then it's like a parabola or something. But some key points are hitting the x-axis and hitting the y-axis, hence finding the x and y-intercepts. The fundamental thing, the most important thing, is that you just plug in 0 for the other letter. So if I want to find an x-intercept, simple, plug in 0 for y. If I want to find a y-intercept, plug in 0 for x. So it zeroes them out, and by doing that on graphs, if I zero you out, that keeps you on one of these axes. So let's think about this. Let's try it. Let's go x-intercept and y-intercept. Now I'm going to tell you, a little secret, y-intercept is always easier because the y-intercept is always a plain number at the end of an equation if it's written in the proper form, which all of these are. So if I just put in 0 for x, that means I would put 0 right there for next to the 4, and then I would have 4 times 0, 0. Essentially that would be gone, and I'd be left with 12. The y-intercept is 0, 12. Okay, it's that last number. It's called the constant, and that constant means it never changes. That zeroes out. This one, I could put zeros in there. Negative 40. The y-intercept for this one is going to be 0, negative 40. Okay, take advantage of that easy stuff like that. Okay, now the x-intercepts always take a little bit more work because you have to put 0 in for y, and if I put 0 over here, now I have an equation that I have to solve. So in solving that equation, I'd subtract 12, I'd have negative 12 equals 4x, divide by 4, and x equals negative 3, so that's my x-intercept, negative 3, comma, I put 0 in for y. So that would answer this one here for the first one. Okay, the second one now, I've got the y-intercept as 0, negative 40 because I did that already by zeroing those out. Now the x-intercept's a little bit tricky because I get 0 equals x squared plus 6x minus 40. Now this is where it gets into, you need to know either factoring, you have to factor this, or you have to use quadratic formula, and then either one of those is going to help you find the two x-intercepts now at this point. I'm going to choose to do factoring. Factoring is another one of the targets. It's actually the next one, so I'll show you more how to do that later in the next R7 video, but here's the deal. It would be x, what makes 40 is 10 times 4, so I'm going to go x plus 10, and then x minus 4, and it's going to work. And then when does this equal 0? Negative 10. When does this equal 0? Positive 4. So then the two x-intercepts would be negative 10, so negative 10 comma 0 and 4 comma 0. So then those would be my two x-intercepts. Negative 10 is what that one says. So negative 10, 0, 4, 0, because it would be the opposite of the factors. Now the same thing is going to happen down here. This thing is not factored. So in order to find the x-intercepts, I have to factor this. And again, that takes practice. But it's going to be 2x and x. And then it's going to be plus 1 and minus 4. Now I took a little bit of time to factor that before I started this video. I'll show you that in the next one. But then when does this equal 0? Well, that's a little bit of a baby problem here. Make a little problem. And then subtract 1 and divide by 2, and x would equal negative 1/2. So now you've got negative 1/2 comma 0 as one of your x-intercepts. And then this one, this would be 4 because the opposite of x minus 4 is 4. And that would be 4, 0 is the other x-intercept. And then if you're looking for the y-intercept is this guy right here at the end, and that would be 0, negative 4. And so those would be your three answers for that particular problem. So if that was too fast, you can rewatch some of this, slow it down a little bit, but there you go.